Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0340, which indicates a CMP sensor A no signal error. This fault can significantly affect engine performance and drivability. The component referred to by this code is the camshaft position, CMP sensor A, which is crucial for the engine control module, ECM, to properly manage fuel injection and ignition timing. If the ECM does not receive a signal from the CMP sensor, it cannot accurately coordinate the ignition events, leading to performance issues such as misfires and reduced fuel efficiency. The CMP sensor is typically located near the camshaft, and on the Honda Civic, it is generally housed in a 3-pin connector, which connects to the ECM. Understanding this code's implications will help us focus our troubleshooting efforts on the right areas. The DTC P0340 indicates a failure in the camshaft position sensor A, meaning the engine control module, ECM, is not receiving a signal from it. The CMP sensor plays a critical role in engine operation by providing the ECM with information on the position of the camshaft, which is essential for determining the proper timing for fuel injection and ignition. This sensor is typically located close to the camshaft, often integrated into the engine assembly. A poor connection or a faulty sensor can disrupt the signal sent to the ECM, causing the DTC to trigger. The 3-pin connector allows electrical communication between the CMP sensor and the ECM, and issues here can lead to severe engine performance problems. When diagnosing DTC P0340, several potential causes must be considered. Firstly, a faulty CMP sensor A is a primary reason, as it may not generate the correct signal for the ECM. Secondly, damaged wiring also plays a significant role in this error. Any fraying or breaks in the sensor wires can lead to a loss of signal. Another important area to inspect is the connection to the powertrain control module, PCM, as loose or corroded terminals can disrupt communication between the CMP sensor and the ECM. Additionally, ensure that no other components in the circuit are malfunctioning. Properly identifying these issues can greatly simplify the troubleshooting process. DTC P0340 can manifest through several observable symptoms. First, you may experience engine misfires due to improper timing caused by a lack of camshaft position information. This miscommunication can lead to performance issues during acceleration, and the engine may feel sluggish. In severe cases, the engine could fail to start altogether or may stall. Additionally, rough idling can be a telling symptom. The engine may shake or vibrate due to inconsistent timing. You may also notice diminished fuel efficiency, as the ECM may not optimize fuel delivery without accurate timing data. Being aware of these symptoms can help you connect the dots during your troubleshooting process. The initial step in troubleshooting DTC P0340 involves confirming the fault. Begin by putting the vehicle ignition in the on mode without starting the engine. Next, utilize the HDS, or Honda Diagnostics system, to clear any existing DTCs. After clearing the code, start the engine and check again for any pending or confirmed DTCs. This is essential to verify whether the error code recurs. If P0340 shows up, it signifies that the failure has been duplicated and you can proceed to the next troubleshooting step. If the code does not appear, it may indicate an intermittent failure. Therefore, it's crucial to check for poor connections or loose terminals at both the CMP sensor A and the PCM. In this step, we aim to isolate the problem area related to the cam position. Start by turning the vehicle to the off mode. Disconnect the 3-pin connector from CMP sensor A to facilitate voltage measurement. Once disconnected, set the ignition to on mode while ensuring the vehicle does not start. Utilize a multimeter to measure the voltage between test points 1 and 2, with test point 1 being the number 1 terminal of the CMP sensor's 3P connector and test point 2 linked to body ground. The expected voltage should be around 5.0 V. If the voltage reads correctly, the VCC2 wire is functioning properly, and you may proceed to the fourth troubleshooting step. If not, additional investigation is required for further evaluation. For this step, we will perform an open wire check to the VCC2 line. Begin by switching the vehicle to the off mode. Use the HDS to jump the SCS, which stands for the system's communication system line, and wait for over 1 minute to allow the system to reset. Afterward, disconnect the PCM connector E, which is an 80-pin connector, and proceed to check for continuity between the number 1 terminal of CMP sensor A's 3P connector and the number 77 terminal of the PCM connector E. If continuity exists, this confirms that the VCC2 wire is intact. Should this wire be okay, you can check for authorized service information related to DTCs or consider substituting the PCM with a known good unit to further narrow down the fault. If the DTC disappears with the new PCM, the original PCM may need replacement. The next troubleshooting action involves assessing the TD cam line by measuring voltage. Make sure the CMP sensor A's 3P connector is still disconnected and turn the vehicle to the on mode. Use a multimeter to measure the voltage between test points corresponding to terminal number 3 of the CMP sensor and body ground. The expectation is to see about 5.0 V. If the voltage levels are as expected, proceed to the fifth step. If not, further investigation will be necessary regarding the TD cam line to identify potential open circuits or shorts. Continuing from the findings in the previous step, we will now check the SG2 line, which is also essential for the sensor's function. Begin with the vehicle in the on mode and the CMP sensor A's connector disconnected. Measure the voltage between test points, specifically from terminal number 1 to terminal number 2 of the CMP sensor's 3P connector. You strive for a voltage reading of around 5.0 V. If both points read this voltage, the SG2 wiring is functioning correctly, which would indicate the need to replace CMP sensor A itself. If the readings are not as expected, you should follow up with further continuity checks on the SG2 line. Having identified potential issues with the SG2 line, this troubleshooting step focuses on verifying wire continuity. As with earlier steps, ensure the vehicle is turned to the off mode and use the HDS to short the SCS line for resetting. Disconnect the PCM connector E, which contains 80 pins. Now measure continuity between test point number 2 of the CMP sensor A's 3P connector and test point number 78 of the PCM-E connector. If continuity is present, the SG2 wiring is intact. In such a case, check for any authorized service bulletins related to this code. Or again, consider substituting with a known good PCM. If the DTC resolves with the new PCM, that indicates specific issues with the original unit. Otherwise, you will need to repair any open circuit found in the SG2 line. Next in the sequence is assessing the TD cam line for possible shorted wiring. Begin by switching the vehicle to the off mode. Then, use the HDS to short the SCS line as a standard reset procedure. Afterward, disconnect the PCM connector E again, and now check for continuity between the PCM's number 43 terminal and body ground. If continuity exists, it indicates that there is a short in the TD cam wire. This requires immediate attention, as it can lead to further electrical issues. Repairs should be made to address this fault promptly. If continuity is absent, you can be reassured that the TD cam line is not shorted. Proceed to the next step for further checks. Finally, turn your attention back to further assessing the TDCM line for open circuits. With the vehicle in the off mode and with both connectors disconnected, check for continuity through the TDCM wire between the CMP sensor A's terminal number 3 and the PCM connector E's number 43 terminal. Should continuity be confirmed, the TDCM wire is intact, and further action will involve checking for any service bulletins or possibly substituting with a known good KCM. If no continuity is detected, there is an open in the TDCM line, and you will need to repair the break in the circuit. Proper diagnosis and repair at this stage is critical to ensure that the engine operates correctly. Once all the troubleshooting steps have been conducted and the potential failures have been addressed, it is imperative to perform a final verification. Start by clearing any stored DTCs using the HDS. Follow this by conducting a test drive of the vehicle under varying conditions to ensure all systems perform as expected. Monitor for any recurring DTCs, especially P0340, as this will guide us on whether the repair was successful. This step is essential, as persistent issues could indicate unresolved wiring problems or a faulty component that may need further inspection or replacement. Maintaining detailed notes throughout the process can be valuable for future reference. Preventive maintenance is critical for ensuring that the CMP sensor and its associated wiring remain operational over time. Regular inspections of the CMP sensor should be performed, especially to check for any signs of wear, fraying, or damage, which can lead to failures in operation. Beyond just the sensor, it's essential to maintain clean and secure connections to both the sensor and the PCM. Consider applying dielectric grease to connections to prevent corrosion. Also, make certain that wiring is properly routed to avoid kinks or pinches that could damage the wires. By committing to regular preventive maintenance, you can significantly reduce the chances of DTC P0340 triggering again. In conclusion, DTC P0340 relates to the crucial function of the camshaft position sensor A and its role in ensuring that the engine runs smoothly. Understanding the sensor's purpose helps us appreciate why its failure can lead to various engine performance issues. By adhering to systematic troubleshooting steps, we can accurately diagnose the problem area and take corrective action. Remember that after repairing the fault, a rigorous final verification process is essential to confirm the repair's success. Lastly, incorporating routine preventive maintenance will enhance the longevity of the sensor and prevent future issues like P0340. Thank you for your attention, and I wish you success in your troubleshooting endeavors. Please like and subscribe to the channel. See you next time.